Hey guys, welcome to Conceptual Geometry, lesson 3.3. Today we're going to talk about the properties of a rectangle. So like we did with parallelogram, I'd like you to grab your green packet and flip to the rectangle shape. And we're going to discuss the properties of a rectangle. So once again, you're going to know something similar with the sides, and that is that the opposite sides are equal. Now, the other thing you're going to note here is that the opposite sides are also parallel. We can't really measure that, but it's kind of obvious by looking at the shape. What makes a rectangle a little bit easier than, I think, a parallelogram, I'm sure you guys are aware of this, is that all the angles are 90-degree angles. So you can say all four angles are equal, or all four angles are right angles, all four angles are 90 degrees. But that's really the defining characteristic of a rectangle. Now, the other thing that's kind of interesting is the diagonals. What's different about the diagonals from a parallelogram is that they are equal. Not only are they equal, but they bisect each other. So what they do is they create a bunch of isosceles triangles. So take a look at this triangle right here. Since these two sides are the same, these two angles would be the same. And this triangle on the bottom is what we say congruent to the triangle on the top. So all four of these angles that I'm highlighting are going to be equal. All right, I'll fill that in with blue. So these two angles here are equal, and they're equal to these two angles here. So all four angles that I just marked with the two blue arcs are congruent. And then, if you think about these isosceles triangles, these angles here are going to be congruent, and they're going to be congruent to the two angles on the other side. So I'm just showing you here two congruent isosceles triangles. All right, so I'll use green for this. That angle and that angle are congruent, and they're congruent to these angles over here. Now remember, it's a rectangle, so this angle here and this angle here have to add to 90. So what's really cool about a rectangle, and you're going to see this in a few minutes, all I need to do is give you one of these little angles, and you can get every other angle in this figure easily. All right, that's one of the cool things about a rectangle. Okay, let's list the properties. Rectangle properties. Opposite sides are parallel. Remember, that's our symbol for parallel. Opposite sides are equal. Opposite angles are equal. You might say, well, wait a minute, I know something else about the angles. Hang on, we'll get there. Adjacent angles are supplementary. And the diagonals bisect each other. So you might say, well, hey, this looks very familiar, and it should. These five properties here are parallelogram properties. All rectangles are parallelograms, and that's really important for you guys to understand. A rectangle is a more specific type of parallelogram because it has all the parallelogram properties. In addition to our parallelogram properties, it has these: 4 right angles and equal diagonals. All right, so in our figures at the right, let's put in what we know. Opposite sides are parallel. So I'll use those arrows to indicate parallel. opposite sides are equal. I'll do that on this one down here so it doesn't get too cluttered. So that means equal in length. Opposite angles are equal. I'm not going to mark those now. Adjacent angles are supplementary. Diagonals bisect each other. So I'll throw in diagonals down here at the bottom one. All right, so they bisect each other. And they're equal, which did not happen in the other one. So this point right here is the midpoint and divides those into two equal segments. The defining characteristics, 4 right angles. And in the figure below, we just talked about it, since each of these triangles are isosceles, that means these corner angles are all going to be equal. So these 4 angles here are congruent, as are these 4 angles. So you can see right away, it's a little busier than a parallelogram was because there's more properties. I know more things. Next question, very important. What does a rectangle always have that a parallelogram does not necessarily have? 4 right angles and equal diagonals. Okay, let's do a couple quick examples and then we'll call it a day for day 3. In rectangle FIJG, if the measure of angle IFG, so we have to trace it, IFG, well, I know right away what that is. This is a rectangle, so that's a right angle. That angle is 2x plus 20. Okay, so this angle here is 2x plus 20. This is about as easy an example as you're going to get. 2x plus 20 equals 90. Subtract 20 from both sides. 2x equals 70. Divide by 2. X equals 35. The question says, find the value of x. Great. Let's move on. A little bit more challenging here. Not a whole lot, but a little bit. It says in rectangle FIGJ, FJ. So where's FJ? FJ is the whole diagonal is y plus 2. So all right, let me color code this. The whole diagonal, the whole thing is y plus 2. And IG, okay, so this isn't as challenging as it could be. That's the other diagonal. That diagonal is 5y minus 10. So since we're talking about the entire length of both diagonals, they are going to be equal, and I'm just going to set these two expressions equal to each other. So I've got 5y minus 10 equals y plus 2. Let's subtract y. At the same time, I'm going to add 10. 5y minus y will give me 4y. 2 plus 10 is 12. Divide by 4. Y equals 3. Again, go back and read. Find IH. Oh, a little tricky. IH is only this piece. So it's half of the diagonal. So what I would probably do first is find the diagonal, like IG. And that's going to be the same as FJ, so y plus 2. 3 plus 2, that's going to be 5. IH is going to be half of that. 5 divided by 2, or 2.5. So at the end there, it got a little bit tricky. The initial equation was pretty easy to set up and to solve, but what they wanted you to find was a little bit more challenging maybe than just finding a diagonal or a side. All right, this will be the last one we do today. This is one of those questions I was telling you about where I'm just going to give you one angle and you're going to be able to give me all the other angles. It's kind of cool. It's not a ton of work here. It's kind of an easy angle to work with, 50 degrees. But first thing I would identify, oh, it's a rectangle. So I've got 90-degree angles. I know this is 90 degrees, which means this angle and that angle have to add to 90. So to get that one, we're just going to take 90 minus 50. I don't really need to show that. That's kind of easy to do. That's going to give me 40 degrees. What I'm going to do next is I'm going to indicate that the diagonals are equal and they bisect each other. So it creates two sets of isosceles triangles. All four of these angles here, here, and here are going to be equal. So since I already calculated this one to be 40, all those other angles are also 40. Now again, here's the other set of isosceles triangles. And I know these angles are all going to be equal here. Since that one's 50, all of these are going to be 50. And then this area in the middle is going to be easy to get. You can pick either triangle, it doesn't matter. So if you want to pick this triangle in the top, you know, that's 40 and that's 40. So this angle here is going to be 180 minus 40 minus 40. So that's 80. 180 minus 80, that's going to be 100. And once you get that one, then you know the one across from it's going to be 100. And then you know these two here add to 180. So if this is 100, that's got to be 80. And it's really quick to get these four angles in the middle. Okay, so this is going to be 100, which means that's 100 because those are vertical angles. And then 180 minus 100 gives you 80. All right, so there you go. Not a lot of work to show, but we got all the angles in that figure. That's where I want to stop for day 3. As usual, guys, if you have any questions, don't hesitate to reach out. Thanks for watching this video, and we'll see you in class soon.